How can we understand an entire population without studying every individual? We can sample a smaller group to make sense of it and reflect upon the bigger picture. In data science, two common approaches are random sampling and stratified sampling. Let's explore how these methods work and why stratified sampling can often provide a clearer picture. Random sampling means selecting items purely by chance. Imagine a jar filled with red, green, and blue balls. If you close your eyes and take a handful, that's random sampling. Sometimes you will get a balanced mix. Other times, you might end up with mostly one color. That randomness can lead to uneven representation. If those balls represent groups of people, like patients from different age groups, and a random sample does not include enough individuals from one of these groups, the analysis could become biased or even misleading. This is where stratified sampling becomes useful. Rather than selecting objects randomly from the entire population, we first divide the population into subgroups based on a common attribute. This process is called stratification, where the subgroups are called strata, and each individual group is referred to as a stratum. Now, find the size of each subgroup in the population. Next, determine the sample size. Then, multiply it by the fraction of the total population that each subgroup represents to calculate their corresponding sizes for the sample. If it results in fractional subgroup sizes for the sample, round them to the nearest whole number. Adjust proportionally if required to ensure the sizes add up to the total sample size. Now, randomly select from each subgroup of the population based on its allocated size for the sample. Therefore, stratified sampling ensures fair representation of every group, reduces bias, and provides a clearer view of the data, making it an essential technique in data science and research.